Okay, now let us take another 2012 problem. It says that the point P is the intersection of a straight line joining the points Q and R. So the Q and point R are given to be 2, 3, 5 is Q, and R is nothing but 1, minus 1, 4. Alright, and it is given that this line QR is intersecting with the plane 5x minus 4y minus z equal to 1. Alright, and that point is nothing but P. So the point of intersection of these two things, that is the line and the plane, is given to be P. Going further, it says that if S is the foot of perpendicular drawn from the point T to the line QR. Let's say this was the point T which is given, and this is the line QR. Okay, and the foot of perpendicular drawn from tree will be something of this. Okay, and this point is given to be S. Okay, and obviously if this is foot of perpendicular, this will be a perpendicular line. Now obviously P point will lie somewhere here, because P is the point of intersection of the line QR and this plane. So obviously P point will lie somewhere on the line itself. What we need to calculate is this distance PS. Alright, we need to calculate this distance PS. And if you have done vector 3D throughout, even if you are cleared with the basics of vector 3D, you'll be able to do this question very easily. So let's see what is required in this question. First of all, obviously to find the distances of the PS, we need to find the points P and S respectively. So now let us see how to solve it. First of all, we'll try to find the point P from the question itself. It says that P is the point of intersection of the line QR and this plane. So if I write the equation of line with using these 2 points, what it would be? It would be x minus 2 by 1 equal to y minus 3 by 4 equal to z minus 5 by 1. Okay, this was easy. You must have done this even in the CBSE step. Alright, and any point in this any point on this line can be taken as, assuming this to be all equal to lambda. So any point would be of the sort lambda plus 2, 4 lambda plus 3, and lambda plus 5. Okay, and if I assume this point to be a P point now, and also the P point also lies on this plane now, so that means this point which I have written in the terms of lambda should also satisfy this equation of the plane. So now putting this in this equation, that is like this, and obviously then solving for the values of lambda, what we can get is the values, the value of lambda that will satisfy this equation. Okay, so solving this, what we'll get the value of lambda as equal to minus 2 by 3. So that means by using this, now I can calculate the value of point P. Okay, now the point P will be nothing but it will be 4 by 3. Okay, 4 by 3 comma 1 by 3, and the z will be 13 by 3. Alright, so half part of the question is already done. We have already calculated the point P. Now we just need to calculate the point S. What we'll use for point S is that TS is perpendicular to the line QR. Okay, so we know the drs of line QR. We will now try and calculate the points, the drs of line TS in terms of point S itself, and then use the property that if they are two perpendicular lines, then the cross dot product of their drs will be equal to 0. Okay, so now again assuming that point S, I can again write the point S in terms of lambda, because again the point S lies on the line QR itself. So it will be again something of the sort, something like this. Okay, no harm in writing anything of this sort. Okay, so this is T point. So what will be the dr of line TS? So this is nothing but we just need to subtract the 2 points. So the drs of TS line will be nothing but what is the T point that is given to us? This is 2, 1, 4. So this is really easy to solve. So what we can say, the drs of TS will be lambda 4 lambda plus 2 and lambda plus 1. I have done nothing, but I have subtracted the coordinates of point S from with the coordinates of point T to get the drs. Okay, now these are the drs of TS, and obviously we know the dr of line QR, which are nothing but what, 1 comma 4 comma 1. Okay, we already have used this in this step, that is the equation of line. So now obviously the dot product of these two drs should be equal to 0, because these two are perpendicular lines. So that means lambda plus 4 times 4 lambda plus 2 plus lambda plus 1 should be equal to 0. Okay, so if you calculate this, what will the value of lambda? It will obviously come out to be lambda is equal to minus half. So by using this, what we can do, we can now easily calculate the position of S. What we have to do, we have to put this value of lambda over here. Okay, so the position of S will come out to be what, 3 by 2 comma 1 and comma 9 by 2. So now you have S P point and S point over here. Obviously by distance formula we can easily calculate the point PS, the distance PS, sorry, which will come out to be nothing but 1 by root 2. So again, this was an easy problem, a bit lengthy though, but it was straightforward problem. Okay.